Everyone, welcome back to the part 2 of the 8th edition of the World Energy Storage Day. Now we are about to start the first session of this forum 2. For this, we invite our first speaker, Mr. John Wood, CEO, Gelion, and he would be talking about advanced battery technologies. Handing over to Mr. John Wood.
Thank you very much. Great to have the opportunity to talk to you today. I'm going to introduce some advanced battery technology. I'm going to put in the context of the supply chain and the future of energy storage today. First of all, to introduce Gelion. Gelion is a Australian and UK based enterprise developing various technologies, including lithium sulfur and silicon sulfur advanced technologies, zinc-based aqueous technologies for stationary storage, and also developing some remarkable lithium-ion recycling technologies that were originally developed inside Johnson Matthey, some novel hydrometallurgical recycling processes for black mass to materials. Okay, our journey in battery technology. It's a very exciting time in our industry. Gelion has been super busy. We started developing lithium sulfur in Sydney back in 2019, but then accelerated very quickly in 2023 when we acquired what was the technology family from Oxis Energy from Johnson Matthey. We then also acquired a wonderful team in the UK, which was Oxlid, led by Adrian Amiguez, signed a partnership with Ironbox to do a silicon sulfur development, and then basically been expanding and building out our capabilities ever since. We see a future of higher energy density, cheaper, safer, greener batteries. We also see a future with changes to the supply chain. So I put up here a slide of today's supply chain. You can see that much of that supply chain is controlled. And that supply chain is dependent on the prevailing technology, which is intercalation. And of course, intercalation is such a powerful method of storing energy in batteries, with the ions going from the anode across the cathode and back in between the plates. It's very, very effective. But I've got a couple of philosophical quotes here for you, because sometimes you need to think outside the boundary. And there is a lot in the world that is beyond intercalation. And looking beyond intercalation offers an interesting future. I like this quote by Bruce Lee: if you put a limit on everything you do, physical or anything else, it will spread into your work and your life. There are no limits. There are only plateaus, and you must not stay there. You must go beyond them. And so I see that the oil industry must also look beyond intercalation. Of course, there is alloying, which offers a path to higher energy density with safety. There is plating, which offers the highest energy density. And then on the cathode side, there's the ability to move to conversion cathodes. And I'm going to talk a little bit about sulfur conversion cathodes, which have higher energy density, very safe, and of course, sulfur is super abundant. All right, this is a great slide that was created by Ken Hoffman at McKinsey. So I'll give the credit for this slide to Ken. He used it at Plug Vault 2023. When I look at this slide and I look underneath this slide, I see this picture. I see a picture where our industry is today based around intercalation. And as we move up into higher energy densities, we start to look to plating technologies and alloying technologies. And you can see down the bottom where I've got the different applications, and then on the left side, sodium, and on the right side, sulfur conversion. But I see a future for our industry where things change up. What happens if you take a sodium intercalation cell, and you add a alloying anode. And that's a remarkable breakthrough by a group in San Diego called Unigrid, Darren Tan. You end up with a cell that has higher volumetric energy density. And so you move sodium up the spectrum there. And then what happens if you take a alloying anode and you add the stability of that alloying anode with the high energy density to a conversion cathode like sulfur? And now you start to get a cell that has super high energy density, but that can cycle really well. And so I think looking at this slide that you see in front of you, I see a very vibrant future for our industry of energy storage, where we're not restricted by intercalation. We make use of intercalation, but also we start to make greater use of alloying, plating, and conversion as well. Some of the advantages of lithium sulfur, of course, it's got a great gravimetric energy density, much lower weight. It has increased safety, reduces the risk of thermal runaway. Lower cost. Sulfur is abundant and available at a fraction of the cost of metal cathode materials. And it can be produced locally. So the materials can be sourced all around the world. Now, we know that we need a 350 times increase in battery production. And we know that we always want to make batteries perform better, higher energy density as we go. Well, this is somewhere that sulfur absolutely shines. We have abundant sulfur, and sulfur is really, really cheap. So if we can unlock the value of this resource, we can, with 10% of the sulfur being released each year, provide all of the world's 2030 air and EV-based battery needs. Now I'm going to look at the supply chain from a slightly different perspective here. And what I'm looking at is traditional, conventional lithium-ion battery materials and the challenges associated with cathode production. By shifting from conventional lithium-ion cathode to lithium sulfur, we can significantly simplify the production of the cathode. But Gelion is taking this even further due to the remarkable work out of our team in Sydney and our team in the UK under the leadership of Lewis Adriansons and Gareth in the UK. We are actually developing methods of self-assembly of the cathode materials in the factory itself. What does this mean? This means a future supply chain opportunity where the cathode could be self-assembled from raw materials under ambient conditions within the gigafactory mixes. Now this changes a lot. Remember, we're dealing with a super abundant material, a low energy process, and now the self-assembly. The environmental benefits are phenomenal. These are all things that we need to start looking to. The carbon debt of production, the cost of production. So huge environmental benefits, dramatically reduced cost, non-specialized ingredients, NMP3, and a capex reduction. And then, of course, now by taking the nasties away from the process, simpler plant siting, simpler permitting, basically simpler regulatory. So we see the impact of sulfur chemistry, not just in performance, making higher gravimetric energy density cells, not just in abundance, but we see it as offering a path to significantly reduce the carbon debt associated with making batteries. And I've got a slide here. This is an analysis of the estimated transport emissions during production and delivery of 1 kilowatt hour of NMC 811. You'll see that the material extraction and the CAM delivery and transport emissions leads to about 733 grams of CO2 per kilowatt hour. Or another way of looking at that, for a facility like the Gigafactory in Reno, that's about 27,900 metric tons of CO2 per year. But what would happen if we were able to move away from this complex metals-based supply chain and to use local materials? So here's a comparable scenario. If we were to move to a sulfur type approach, basically the cathode material is sulfur, carbon, and binder. So here you can see now those numbers are significantly lower, that we're at around 24 grams of CO2 per kilowatt hour, or about 912 metric tons per annum. The numbers here are huge as we start to scale our industry. So if I was to put those contexts for you, Gelion takes it one step further, which is this self-assembling approach means that even less CO2 is produced in the course of making that cathode material. So looking at the comparison, in the future, sulfur offers a path where we can go from 10.36 kilograms of CO2 per kilowatt hour in making an MC to around 0.023. And this is going to become increasingly important. So I started off introducing for you the concept of lithium sulfur advantages in terms of low gravimetric or high gravimetric energy, in terms of safety and abundance. But I want to also give you that picture of that future supply chain, that there is enough sulfur in the world to actually meet the long-term energy durations that we need to be able to meet the transport that we need, the volume of the transport we need, and also the supply chain advantages. Yes, you can get the materials where you are. Yes, it has very low CO2 emissions, low energy production, lower costs, and produced locally.